Okay, let's try that again. Day 11 seems to be working. Hopefully it goes better than yesterday. And let me make sure that I am capturing sound, and it seems like I am. So let's go, day 11. Do you finally start making use of fractional sliding or what goes to fly your head? Monkeys are playing keep away with your missing things. Your stuff back, you be able to predict where the monkeys will throw their items. After some careful opportunities, you use monkeys to operate based on how worried you are about each item. Take some notes on the items each monkey currently has, how worried you are about those items, and how the monkey makes decisions based on your worry level. Um, um, each monkey has several attributes. Starting items, list your worry level for each item the monkey is currently holding. Operation shows how your worry level changes as the monkey expects an item. Operation like new equals old times 5 means that your worry level after the monkey inspecting the item is 5 times whatever your worry level is. Test shows how the monkey's worry level decide where to throw item next. If true, after each monkey inspects an item before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the next integer. The monkey takes turns inspecting and throwing item. So the monkey starts inspects and throws all the items it is holding one at a time and in the order listed. Monkey 0 goes first. Monkey 1 is the monkey throws the item. That item goes in the end of the time. Monkey lets monkey started with no item. Could end up inspecting and throwing many items by the time so no items starts out turn ends. Items, these worry levels, these worry levels, these worry. You have to focus 2 most active monkeys. Count the total number of times each monkey inspects items. This example. All right, this seems complicated to get right, so let's try it. Okay, so let's just say raw equals this, and a monkey is an operation. Okay, so from data classes, import data class and field. I learned that trick yesterday. And let's say data class monkey, right? Name. I don't need a name. What I need is items, which is a list of int, which is that. Okay, an operation, which is an operation. And a test, which is a test. Okay. And then, so here's what I'm going to do. From typing import callable. Okay, and so what is an operation? An operation is a callable which takes as input an int and returns an int. Okay, and a test is a callable which takes an int and also returns an int. Okay, so an operation takes old and returns new, and a test takes old. A test takes worry and returns a monkey ID. Okay. Okay, so I don't want to use data class here because it doesn't. Self items, which is a list of ints. Okay. I can't see because it's too wide. Self.items equals items. Self.operation equals operation. Self.test equals test. Okay, so that seems good. Okay. No, I don't need to do that because these are going to be callables. And we're going to do static method from string. Yep. Okay. And let's do this just because it makes sense. Self.id equals ID. Okay, good. So that's what it looks like. Okay. Lines equals s.split lines. And let's say ID equals, I don't want to do that. I want to do it with a regex because I don't trust that it's just one digit, right? Well, I might do it with regex. What I might do is I say monkey is ID equals lines 0 split -1. Okay, so I split it on this base, take the last one, and then dot replace. I'll just be more explicit about this and get rid of that, and int of that. Okay, that's good. Items equals int I for I in line 1. So what do I want to do there? There I'm going to split on the colon. Okay. And then -1 split on the comma. So that's right. I'm gonna have to zoom out because I can't see this. So I think that's right too. And then operation equals, yep. And then test equals monkey dot parse. I don't need to, sure, I can make this static. And this is actually lines 3 through 6, okay? And return monkey ID. Okay, that sounds good. Okay, so now static method, parse operation, yes. Okay, and an operation is a function that takes an int. Wow. New equals, so operation, so let's see, new equals s dot split on equals, I think, right? Split on equals -1 dot strip. Okay, so now I have something, and now it's always going to be 3 things. And then let's say L op r equals new dot split. Okay. And then we could have old times old plus, old times old, old plus. Okay. And then let's say match LR. This might not be the right way to do it, but case old. Um, you know what? Let me just do it explicitly. It'll be easier that way. Okay, old times old. Yep. Case old plus old. Okay. And then this is going to be super tedious. Let me do this. Import operator. And so function equals okay. If op equals this, function equals operator dot mul. Lf op equals plus, function equals operator dot add. Lf op equals minus, function is operator dot sub. Lf op equals, this is probably not even valid, but we'll do it anyway. Okay, let's do that. Okay. And then this will make our lives easier than writing out every single case. Case old. No, old return lambda x function xx. Case old n return lambda x function xn. Case n old return lambda x function nn. And then I don't know why it would do this, but it might. So I think that's right. What doesn't like? Must return value. Invalid operation. Okay, and I just thought of something that bugged me. What did it bug me? What bugged me was that this should be int L and int R, and then it's okay. Okay, good. And now I need to parse a test as well. So def parse test, and now test if true, if false equals lines. And let's just say monkey if true equals int if true. Yep, that's right. Monkey if false equals, yeah, that's right as well. Okay. That seems right. if split, take the last piece and take int of it. And so I just do the test. And then all these tests seem to be divisible by, let me just double check my input and make sure that that's really going to be the case. Yeah. Okay, well that's easy enough then. And then y equals int test.split minus 1 and return lambda x monkey if true, if x is divisible by 0, else monkey if full. Yes, that seems right as well. And um, and let me just do one more just to make my life easier. Static method def parse all, which is going to be monkey for string and split on double new lines. Okay. Okay, and let's say monkeys equals monkey.parse all raw. So let's try that and see if it gives an error. Okay, so that's right. So that was a bad idea. So what I need to do, I'll just need to do it here. Okay, let's try that again. That seems to work. Okay, so now that we've done all of this, let us go back and look at the problem. Well, now that I've got this, why don't I at least stick it here. Okay. So now I need to, now that I've parsed them, which took a bunch of time, and now what I want to do is, this is, monkeys are playing keep away. Okay, so I'm going to call this class keep away. This is your worry level for each item the monkey is currently holding in order to be inspected. Operation shows how your worry level changes as that monkey inspects an item. An operation like new equals old. Okay. After each monkey inspects an item, but before it tests your worry level, worry level changes as that monkey inspects an item. Your worry level after the monkey inspected an item is 5 times whatever your worry level was. After it inspects an item, but before it tests your worry level, your relief causes worry level to be divided by 3 and rounded down to the nearest integer. On a single monkey's turn, the process monkey. Okay. For monkey and self monkeys self dot take turn monkey. Okay. And then what happens? When he throws an item, a monkey that starts around with no items could end up expecting throwing many items. Around one, both inspect items through them all. Count the total number of times each monkey inspects item over 20 rounds. So self.inspection counts equals 0 for in actually, let me do it this way. Monkey.id 0 for monkey. Okay. Inspects and throws. All the items is holding one at a time and in an order listed. Okay. So take turn, self, monkey, monkey. And I think that's going to return none. Okay. Let's just say for item in monkey.items. And so it's going to throw all of its items. So I have to, let's say remaining items equals this. And then monkey.items equals remaining items. Okay, so because anyway, you'll see why in a second. For item in, and let me actually just call it for worry level in monkey.items. So first I inspect. So self.inspection counts monkey IDs plus equals 1. Inspects and throws all its items. Worry level equals monkey dot operation on worry level. That seems right. And now, because it said there was relief, right? So after each monkey inspects an item before it takes a relief causes it to be divided by 3 and rounded down. So that means relief worry level equals worry level divided by 3. And then we have to test it. Monkey to throw to equals and could I ever throw to myself? Let's see if I need to worry about that. 142035. So no, it doesn't look like I can ever throw to myself. So okay, let's say target equals monkey.test worry level, and just to double check, assert that target. Okay, and then throw self monkey's target items dot append worry level. Oh, so there is no remaining items because everything's going to get thrown. And now, so then what I want to do is I want to say monkey.items.clear. Okay. Item equals, wait, no, what? I don't, did it insert that for me? Did it just, hold on, I don't know where that came from. I think it inserted it for me. So I inspect, count my inspection count. I apply the operation on the worry level. Then I relieve myself. Then I test. then and then I throw, and then I clear my items. Okay. Um, First rounds. And now let's just say I'm going to add a ton of print statements, and I apologize for that. But print what is this? Okay. Print. Okay. Print. Okay, that's good. And now print. Even called it relief. That's nice. Print. Okay. Okay, and let's say keep away equals keep away monkeys, and then let's just say keep away dot round. And let's run this and see if it does what we think it's supposed to do. Monkey inspects worry level 9 multiplied by 1501 divided by 3 to 500, target 3. Inspects level 98, 1862 divided by 3 to 620, sent to monkey 3. Okay. And then we go to monkey 1, 54, worry level 20 to 0, 65, worry level 23 to 0, 75, worry level 27 to 0, 74, worry level 26 to 0. Then we go to monkey 2, 79, worry level 2080 to 1, 60, worry level 1200 to 3, 97, worry level 3136 to 3. After round 1, so let's say monkeys 0 dot items, monkeys 1 dot items. Okay, so let's run this again. No, I don't want to do that. But what I want to do is I want to do keep away dot round again, and then let's do monkey 0 dot items and monkeys 1 dot items, and then monkeys 2 dot items. Okay, so it seems like I'm doing the right thing. After round 10, after round 15, after round 20. Count the number of times each monkey inspects items over 20 rounds. For blank in range 20, keep away dot round, print keep away dot inspection count. So let's do that. 101, 95, 7, 105. Okay. The level 2 most active monkeys, can we figure out which monkeys of Chase County has over 20 rounds? What level of monkey business? Okay, so let me just write a function that does that. Def monkey business level, which is monkeys, which is, let me do a game, which is a keep away, and int, and let's say for blank in range 20, and let me do none rounds int equals 20 for something in range num rounds, run around to the game, And then let's say ICs equals game.inspection counts equals sorted reverse equals true. So we're going to take the two biggest ones and return IC0 times IC1. And now equals 10605. So let us try that and see if it works. That works. Okay, so now with open day11.text as f, raw equals f.read, and let's say monkeys equals monkey, let's say monkeys equals monkey.parse all raw, keep away equals keep away monkeys, print monkey business level keep away. Copilot is not being as helpful as I'd like. 6, 7, 8, 30. Okay, so let's try that. Okay, good. Your worry the amount navigator eyes wax already 5 your relief. The monkey suspect didn't damage the no I'm worried by 3. Unfortunately, that relief was all the keeper improvement. So let me find another way to keep. At this point, you might put in this for a very long time, possibly 10,000 rounds. With these new rules, you can figure out after 10,000 rounds. Worry levels are no longer divided by 3 after each item is inspected. You'll need to find another way to keep your worry levels manageable. Starting from the initial state in your puzzle input, what is the level of monkey business after 10,000 rounds? So the problem being that after 10,000 rounds, these numbers are going to get real big. Okay, so the thing I'm thinking is that when I do a test, I need to know if a number is divisible by something, right? And so I can always mod by that. And so let me write out what I mean is that want to know if A plus B is divisible by C, same as if A plus B if not mod by C anyway. And same if yeah. So basically what I can do is the only thing which is a pain, which is that I'm going to need to modify okay, well, let me do something. F equals lambda xx, f dot modulus equals 10, f dot, okay, good. So okay, so now let me do this. Oh no, I don't need to change the operation. I need to change the test. So now let's say test equals this, and let's say test dot modulus equals divisible. I'll just call it test dot divisible by, except I didn't call it that. And now I can return test. Okay, so this is one of the joys of Python, is that I can just add information like this. And um, now let me what I need to do is um, uh, use relief equals true. Okay. Um, and we'll say self dot use relief equals use relief. Okay. So if self dot use relief, worry level equals worry level divided by 3. And then modulus worry level equals worry level mod monkey dot test dot divisible by. And now I can test it. And let me make sure that this still works and I didn't break it. Assertion error. Okay, so that didn't work. And let's see. It's probably this thing I did which broke it. So let's see. Right. Let me think about what I did wrong there. So I did something wrong. So I'm going to test if something is divisible by 17. I'll just mod it by 17, and then the test is testing that again. So I don't want to do, well, that should be okay actually. Because if it's divisible by, then, well, anyway, let's see what I did wrong. 67,830, and it was supposed to be that. So, and now let's do keep away dot round and see what happens. Let me do that again, sorry. It's fine. Let me add this. because the test is, no, that should be fine. Um, target monkey 3, target monkey 3. And now let us do monkeys 0 dot items and monkeys 1 dot items, and then monkeys 2 dot items and monkeys 3 dot items. And then, so let us go back and look at this. So the first monkey has 20 divisible by 23. The second monkey has 19. So first one mod by 23. Okay, well that's not right. He's modding by 19, it looks like. And the second guy is modding by 17. So monkeys 0 dot test dot divisible by is 23. Is that right? Monkeys 1 dot test. Okay, so that's right. So let's see what I did wrong. Because I probably want to do it after I throw it, not after the. No, that shouldn't. Yeah, maybe that should matter. Let me think about this for a second. For 10,000 rounds, the monkey business is now this. Reloads are no longer divided by 3. We need to find another way to keep reloads manageable. Okay, so let me think about this. You know, I get it. Okay. So I want to mod by the product of all of them. That way, yes, okay. Self.modulus equals 1 for monkey and self.monkeys. That. So that's what I want to do, I think. And now, modulus. Yep. And print worry level after. So that way I'm not affecting any of the divisibilities because I am doing the modulus by the product of all of them. So good. And now I probably need to take out these print statements if I'm going to run it for 10,000 rounds. Yeah. Okay, so now let us say after 10,000 rounds. With these new rules, you can still figure out the monkey business. So monkeys, and then use relief equals false. And then let's say keep away dot round, and then keep away dot inspection counts. Two, 4, 3, 6, and then for range 19, keep away dot round, and keep away inspection counts. 99, 97, 8, 103. Okay, good. So I think we're good now. And so 10,000 rounds. Okay, so assert that monkey business level equals this. So this is keep away monkey dot parse all raw, use relief equals false, nr equals, what was it, 10,000 rounds? All right, let's try this. That passed. Okay, good. So let's print monkey business level. So I'm gonna have to do this again because I messed it up. Let's say use relief equals false. Monkey business level, keep away, NR equals 10,000. Okay, so let's run that. And it is this large number. So let us try that. That's the right answer. Okay, good. So, not a lot going. There's a lot going on here. I guess I didn't use data classes, and I didn't use that regex either. And so the key things were, one is always the parsing. Figuring out how to parse this stuff. And then just like following the instructions carefully and doing it. And then the second part was recognizing that, I mean, they gave you that hint that, once you didn't do this relief, the numbers were going to grow unwieldy big, 10,000, 10,000s. So you have to do something to keep them small. What you obviously want to do is mod them. And then I did the wrong thing, which was to mod each one by what that test was divisible by. But the problem is that if I do that, it's going to break all the other tests divisible by. So if I mod something by 5, it's not going to change the divisible by 5 test, but it is potentially going to change the divisible by 7 test. But if I mod it by 35, which is 5 times 7, it's not going to change the divisible by 5 test or the divisible by 7 test. So what I need to do is, and so really what I need to do is the least common multiple. Now 3, 11, 7, 2, 19, 5, 17, 13. So these are all prime numbers. So the least common multiple is just going to be their product anyway. So basically, I needed to do two things. One is I needed to um, now because the tests themselves were all just divisible by, I didn't need to do it this way necessarily. I could have just kept the modulus anyway and used that as the test. I wrote it slightly more general so that the test could be like anything. Um, but and so because of that, I had to like hang this divisible by off the test, which is a cutesy thing to do. And then all I needed to do was just keep track of this product so that um, I can do the modulus after each thing. And again, because it's the product of everything I'm going to mod by, it's not going to change the divisibility of any of them. So modulating by a bigger number. You could say it's dumb of me to have screwed it up the first time, but I'm not always that smart. So um, I screwed it up the first time, got it right once I realized what was wrong. So good enough, right? Um, and that should be good. So thank you. 51 minutes, seriously? All right, took a long time. Cool.